Yeah, so there's a couple of ways the book gives to name epoxides. The simplest way is like the ether nomenclature. Okay, so remember ether, common names for ethers, but this is the systematic. The common name for ethers is to say the groups on either side in alphabetical order. It's like methyl, ethyl, ether, and that becomes the name. Okay. The simple way to do ethers is to say, oh, sorry. Yeah, sorry. Oh, dang it. This one here, actually, this one at the bottom, is more like the common naming for ethers. So the simple way to do epoxides is more like the common way of doing ethers, and that is to call the three-membered ring oxyrane. That's a three-membered ring with an oxygen replacing one of the carbons, and that becomes the number one atom. Okay, so there's a bunch of these singly substituted cyclic compounds that have special names. And so I'll show you that in a second, but this is just one of them, okay? So if you want to name this, then what you do is you say 1, 2, 3, and in this case, then you put the substituents in alphabetical order, so whichever one comes first, that gets the number 2, okay? So this one is ethyl, and this one's methyl, so that's why the numbering for this compound started here and went around this way. And so now this becomes 2,2-diethyl 3,3-dimethyl oxyrane, and oxyrane is the parent of that system. Okay. The other way to name epoxides is to call it an epoxy, but you know, an epoxy, if it's attached to a parent chain, so it's a substantive name or you make substitutions to put the name in, epoxides are connected at 2 different carbons. So what you do is you tell the people which 2 carbons connects the epoxide ring. And so the parent, notice this is the same compound as this one up here. The parent is the 5-carbon chain. That's the longest chain. And then it's connected between carbons 2 and 3 by an oxygen, so that becomes a 2,3 epoxy. Okay. It follows the same rules. If this had been alphabetical and there had only been 4, then you would have chosen this as 1, 2, 3, and 4 if the 5-carbon hadn't been there, because that's the ethyl group. Right, and then that means this would have been the 2 and this would have been the 3. So what I was just saying here, just to do it in drawing, if it had been like this, let's see. Actually, I don't know if there's a way I can do it real easy. I was going to say if you did it like that, but then it's the same length on either one, so it doesn't really matter. But if it had been so that these were ethyl groups, should have thought about this more in advance. Maybe if I do it as a butyl? Yeah, there we go. If it had been that, right, then the number 1 carbon would have been this one on this end. 1, 2, 3. Because you could number it, and the first substituent comes off at 3 from either side, but then alphabetically that's ethyl, so that comes first. Okay. Does the epoxide need to be on the parent chain? Yeah, so it's on the parent chain. If it's not on the parent chain, if there's a longer chain and it's not on the parent chain, then it becomes a substituent on a substituent. So you have to name the substituent with the epoxy functional group on it. I'm not going to get too crazy on this, to be honest with you. Epoxide nomenclature has made me crazy for years. Because there's actually another way to do this, which is probably a better way. Just going to tell you. And so anyways, I don't know, and I don't have enough experience with epoxides to like know like what's the best way, but that's a bicyclic system, right? So it could be 1,2 epoxy cyclohexane, or it could be a 4 let's see, a 410. Yeah, a 410. But you'd number it like this: 1, 2, 3, 4, 5, 6, and this becomes 7. Sorry, that one looks like a methyl group. Let me get rid of it. So that's a bicyclo, but the number 7, because it's an oxygen instead of a carbon, you call it 7-oxo, and then it names exactly like the bicyclic ring structures that we've learned before. I think that's the more preferred way to do it, but the book shows these other ways. And anyways, they're all acceptable. So I will give you something simple to name. You could choose either one of these methods. If you want to learn the oxo nomenclature, fine, learn the oxo nomenclature. I don't care, honestly. You'll get one of them, maybe, okay? Well, let's just say you'll get one, so it forces you to actually look at them. And it'll probably be a draw the structure from the name thing, so then you don't actually have to remember all the rules. You just can take the name and draw a structure from it, if that makes sense. Anyways, I told the class yesterday I hated this, and then I got myself into this problem where I had a problem and I couldn't name the structure because I was looking at it going, oh, I don't know. So I'll show you that. I'll actually do the problem with you guys. I still am struggling with it. Okay, so talked about oxirane being a ring system. Okay, like this is a 3-membered ring with like a cyclopropane, but with an oxygen in it. This is a cyclobutane with an oxygen, so it's oxetane, oxalane, and oxane. And really, I'm only showing you this slide because I think it's important that you know this compound. Oops. This is dioxin. So technically it would be 1,4 because the oxygens are in the 1 and the 4 positions. So this dioxin was a big deal back when I was in college because when they discovered dioxins, it was in pesticides. It was a byproduct of pesticides and was sprayed on fields. And then what they found out, it was like super mutagenic. And they're like, uh-oh, that sucks. And then, because they were testing it on mice, and it was creating tumors and stuff in mice. But later, what they found was it promotes tumor growth in mice, but really not that much in humans. That's one of the reports that I heard. And I don't know where the research ended up, to be honest with you. So you should maybe do a little reading on it. But it's really common to see dioxins in the literature. And the name comes from the oxane ring system. Yeah, so the joke was it's the most cancerous, most dangerous cancer-causing agent in the world for mice. So then they're like, oh, well, maybe we should spray it around. I don't know. I don't know. It probably goes up the food chain and does some horrible things, so we should probably avoid it. But yeah, so oxirane, oxetane, oxalane, and oxane all sound the same. The only thing that's different is the letters in the middle of the name. The most reactive of these, though, this is also an important concept, would be which? Yeah. Oxirane, because it's a 3-membered ring. There's a ton of strain. It also opens up the bond angles because the 3-membered ring has 60-degree bond angles. And that 60-degree bond angle means it can be attacked by a nucleophile, even though it's tertiary on each of those carbons. You could have a tertiary carbon over here on these guys like this. It's still susceptible to nucleophilic attack because that 60-degree bond angle in the epoxide ring causes those other angles to open up. Okay. Man, this is the one I've been trying to figure out. This thing's been making me crazy. I get 90% of the name, and then it's like that last 10%. And I'm just going to tell you where I am in the struggle so you You can see it. Probably even shouldn't tell you these things, but 1, 2, 3, or 1, 2, 3 the other way, right? This is epoxy. Okay, so in this case, the parent is cyclohexane. And it could be between 1 and 2, or it could be between 2 and 3, depending on which way you, the epoxide could be 1 and 2 or 2 and 3, depending on where you start the numbering, right? So this is an epoxy group, and this is an ethoxy group. So it's tied, sort of, like which way you number it from. So which do you think is 1? Well, ethoxy comes, yeah, epoxy comes before ethoxy, doesn't it? Oh yeah, it goes the other way. Nice. So, unless I'm spelling it wrong again. 1, 2, 3, 4. So it's 1, 2, epoxy cyclohexane is the parent. This part's easy. Internet's being really slow. And then it's 3, this goes in the front, 3 ethoxy. Oh no, I did that. Yeah, epoxy's before ethoxy. Golly, sorry. Because P is before T in the alphabet. Yes. English is my first language, although it doesn't seem like it all the time. Okay, now I have to do R and S, and so that's actually pretty easy for 3 of the atoms, or 2 of the atoms. In front of all that, yeah. Yeah. So that's the parent. Well, the parent's the cyclohexane. The epoxy goes next to that, and then ethoxy goes before that. And now you have to do R and S. So this guy's inserting there. Oh, it would be, huh? Yeah, I'm doing the alphabet part backwards. I told you. Okay, I had the numbering right the first time I did it, right? And then I brain farted. Well, thank you for stopping me on that so late. So it should go like, oh, I see what you're saying. Yeah. The numbering was right. Right. Yeah, goes in there. And this was 1, 2 still. I told you I don't like this. I haven't even hit the part I really dislike a lot. You'll see it when I try to do it. Okay, so we're going to do RS determination. So I'm going to change the pen color. So that's 1, right, because it's an oxygen. I'm doing carbon number 3 first, because that's the easiest one. And this is 2. So this is going like this. So it looks like it's R, right? Because that's the R direction. But what do we know? Hydrogen's in the front, right? So it's actually S, yeah. So 3 is S. Okay. Now, I don't know when you walked in if you noticed that structure was drawn like several times, and I was trying to straighten something out, and I never got it straightened out. Now, the next one that's easy, we'll do number 1. Okay, so we got to determine what number 1 is. So for the number 1, let me use blue for that, actually. That's 1, because it's the oxygen, right? This is 2, like that. That bond that goes between, on the epoxide, between 1 and 2, that's the number 2, because when you go from here to here, that's a carbon. That's also a carbon, so that's a tie, right? But then this one branches up to an oxygen, right? So that becomes number 2. So that one becomes S, because the hydrogen is in the back. So it's going like this. So 1 becomes S. Now you have to do number 2. So do you mind if I erase the stuff that's on there? You guys got that okay?
3 is S, isn't it going in the same direction as R?
No, but the hydrogen's in the front. Yeah, remember the hydrogen thing. So I'm going to erase this. I should maybe have you guys do this, because you guys are probably a lot better than this than I am, to be honest. This is obviously, so now we're doing carbon number 2. All right.